Thank you so much, folks, for coming today. And thank you for joining us for this exciting talk that we have lined up for you today. Today, we're going to be talking about generative AI agents and its applications in the real business world. There is a lot of hype around generative AI. You might have seen that from a lot of sessions today. And our combined aim today is to help translate some of that hype into real business impact. My name is Gaurav Kaila. I lead the prototyping team for UK and Ireland. And today on stage, I'll be joined by Andrew Shannon, who's the head of AI and Cloud at TP ICAP, and Ifa Ojomo, who's a prototyping architect at AWS. We have a packed agenda for you today. I'm going to start by talking about generative AI agents and why I think it's one of the must-have in your generative AI toolkits. Next, we'll be joined on stage by Andrew Shannon, who will talk about TP ICAP and his generative AI journey with AWS. Then, Ifa's going to come up on stage and make it all real for you. She's going to talk about how we implemented generative AI agents with TP ICAP to solve some of the more critical business problems. At the end, I'm going to round up the session and help you understand how all of this could help you. So stay till the last bit. There's an exciting news for all of you towards the end. Let's get started. Now, with the advent of large language models, machines have a remarkable capability of retrieving, analyzing, and synthesizing natural language. Now, this is a large leap from traditional machine learning models where the remit was localized to the training data. Hence, generalization was an issue. As humans, we can not only understand context and data, but take actions on behalf of that context and data, using that context and data. Now, how do machines, empowered with the power of generative AI, do the same? That is, can machines simulate human behavior? Now, this was a challenge that was posed to a young Stanford undergraduate student that came up with the initial idea of generative AI agents back in April 2023. Before we start talking about generative AI agents and how they work at a high level and also deep dive into how they work under the hood, let's talk about some of the workflow challenges that businesses typically face today. A lot of businesses, a lot of people, a lot of critical workers in businesses are overstretched. Some folks in those businesses are the single point of contact for heavily critical tasks, and they're in dire need of technology to help augment their work. We all know foundational models or large language models in general are very good at pulling information from external internal databases and giving you that information in a nice, easy to read natural language format. What they're not good at is taking actions on that information. Now, customers and companies have internal external databases that they're connecting these foundational models to take actions on their behalf. But this integration carries a large technical debt, both in terms of implementation, but also in terms of maintenance and upgradation. Generative AI agents helps to alleviate some of these problems. Let's look at how agents work at a high level. Agents are nothing but planning engines. And there's one thing that you can take away from today's session is think of agents as planning engines. There are a few key ingredients that make up an agent. Instruction. Instructions are rules by which agents abide by. You give it an instruction and you tell, this is how you need to act. Actions. As the name suggests, these are actions that agents can take on behalf of the user. Knowledge bases. Internal repository of your business information that you can give the agent on behalf of which it can act. All of this will become more clear in the next slides. And finally, the brain of the agent itself, a foundational model. For this example and all the examples for the rest of the session, we will consider the foundational model to be from our Amazon Bedrock service, which is our service for building and scaling generative AI applications. Let's look how this template works in action. This is a very simple agent. I didn't give it any knowledge base or any action. It has a foundational model, of course, as a brain of the agent. The instructions given to this agent is to be a joke bot. Just tells jokes, nothing else. So when I ask the agent, can you tell me a joke? It tells me one, a fairly bad one, but still tells me one. But when I ask it to tell me, do a follow-on action from that, it cannot do it because it doesn't have any actions. Let's look at a more significant example, a more useful example. This is a meeting assistant whose instructions are to summarize meetings and send meeting notes to a specific set of attendees. Here I'm asking the assistant to use two sets of action groups. The first set of action group is meeting actions that the agent can use to list a set of meetings, and from those meetings, get action items of those meetings. The second set of actions is utility actions. It can take these actions to extract a list of email IDs for a list of people and send emails to those set of people. So when I ask the agent, can you give me a list of action items for a set of for a set of meetings? It does that by accessing the meeting action group. Now, based on the action that it takes out, I ask the agent, can you send these action items to a list of people? It taps into the utility actions groups, gets a list of email addresses, compiles that email, and sends it over to the set of people. Here, there is no knowledge base that you have given to an agent. So it's just as actions, no knowledge bases. Let's look at another example. It's an HR policy assistant. Here I'm asking the agent to help employees understand their vacation policies. And hence, I give the agent the knowledge base which contains the vacation policies for all the employees. So I ask the agent, if I go part-time, will I get any vacations? And it responds back with what it extracts from the knowledge base itself. It cannot perform any action on top of it. It just gives us the information that it gets from the knowledge base. Now let's combine these two examples together. An agent that has a knowledge base and an agent that has action. Again, another version of the HR policy assistant. I ask the agent to help me understand what my vacation policy is, and if I have any vacations left, can you book these vacations on my behalf? I give it the same knowledge base I gave it in the last example, and I gave it an HR action to book vacations on my behalf. So when I ask the agent, do I have any vacations left, or how many vacations I have left, agent tells me I have X number of days left, and I ask the agent, that's fine, can you book a particular set of vacations for me on a specific set of dates? It goes in and performs that action because I've given it the action to perform under the hood. Hopefully this gives you a high-level idea of how agents operate. Let's look at two critical features that make agents really helpful in implementation in a business setting. First is security. Now, you might have heard this through the sessions, if you attended a few sessions. Security is job zero for us at AWS. Anything and everything we build at AWS is kept with security in mind. And the same thing is with agents and all its corresponding resources, from actions to knowledge bases to the foundational model that you use with Amazon Bedrock. What does that mean to a user? You can limit the use of the agent and the underlying data sources to a set of individuals that originally have access to that data. So if you're building an agent for your IT department, only the IT professionals can use that agent. Or you can open it up to whosoever you want, but you can limit the access only to the folks that you want the agent to correspond to. The second feature, which is heavily critical, and I alluded to that in the workflow challenges slide, is agents are able to integrate with your internal and external databases in an easy-to-use natural language interface. So there's no need for you to build that integrations with your databases. Agents are able to do that in a simple, easy-to-use natural language interface and secure your databases so that it can only be accessed by the set of individuals. Now, this was just a high-level idea of how agents work. So you know how agents work and what sort of capacity they can operate in. Let's go a level below. Let's deep dive into the internal workings of an agent. Now, as I previously said, agents are nothing but planning engines. Given a set of instructions, knowledge bases, actions, foundational model, it gets a set of tasks to perform internally that it thinks it can solve the task that you've given it. Each task is evaluated before it goes to the next task. It's how a human thinks as well. If somebody gives us an action to perform, we think about it, break it down into consumable chunks, evaluate each action before moving on to the next one. That's how agents perform as well. Let's look at a more detailed flow of how this works. Now, there's a lot going on in this slide, so bear with me as I break it down for you. Again, center of all of this is an agent. You will give the agent an action, knowledge bases, instructions to execute. All of this is passed into a foundational model, which is the brain of the agent. The foundational model is responsible for breaking it down into what we call the chain of thought. Again, as a human thinks about an action, agents think the same way. A chain of thought, which is a set of steps that it thinks it needs to perform to execute that task. Now, each step could be accessing a knowledge base, accessing an API, or combination of both of them. Once it gets the raw results, and this is the key element, raw results of each of this step, it passes this back to the agent, that in turn passes these raw results back into the foundational model, that in turn converts these raw results in an easy-to-use natural language interface. So when you saw the examples previously, you would have seen the agent is responding to something that we clearly can understand. But in the back end, it's synthesizing a lot of raw results that it's been given to. Let's look at an example here, which hopefully makes it a lot clearer, right? In this agent, I'm asking the agent to perform a single task. Get me a list of claims where there is missing documentation and get me the documentation requirements for the missing documents. Agent gets this task, has the corresponding underlying data for it to operate with, and starts to think what its chain of thought could be. The first step in the chain of thought is to get all the open claims. So it might access an API or a knowledge base to get all the open claims there are. Once it gets the open claims, it starts to understand what missing documents are there in those open claims. Again, it can access an API or a knowledge base to do the same. Once it gets the missing documents, it tries to understand what are the documentation requirements for these missing documents. Likely, it will access a knowledge base with all the requirements for all the documents that it needs. Once it does all that, it compiles the information, maybe in a single email, emails the claimant to say, this is what you're missing, and this is what you need for us to proceed further. I referenced to instructions quite a bit in my last few slides. So let's spend another 10 seconds on understanding what instructions are. Instructions are rules by which agent abides by, right? These are precursors you can give to an agent so that it operates in the same way every time. You're not going to use an agent just for one task. You're going to use the agent for multiple tasks by multiple users. And it's very important they act in the same way. For example, here I'm asking the agent not to hallucinate, not to make up any false information. I'm giving it some metric conversions, such as one word is X tokens. It understands that and keeps that in its memory while performing any action. Now, summarizing the benefits of agents, some of it will already be clear to you. But there are three major benefits of agents. First, it helps you orchestrate multi-step processes in a single, easy-to-use natural language interface. You are not telling the agent how to break out into steps. The foundational model, the brain of the agent is telling it how it needs to orchestrate each and every step. Security. All of this is built with security in mind. All of the resources internally that it uses, knowledge bases, actions, are secured down to the user level. And finally, the full end-to-end infrastructure provisioning. Once you give it the knowledge base, all your APIs, it orchestrates all of that on your behalf and gives you the full infrastructure provisioning. I'll pass it over to Andrew now. We'll talk more about TP ICAP and their work with generative AI.
Thank you, Gaurav. My name is Andrew Shannon. I'm the head of AI and cloud at TP ICAP. I'm going to talk a bit about our approach to generative AI and a bit more about the partnership we've had with AWS and the generative solutions we've built using the agent technology. Okay, so first a bit about TP ICAP. We are a financial services company based here in the City of London. We've got founded in 1866, we've got trading operations now in 27 countries across the world. We're a leading provider of market infrastructure and data solutions. And essentially what we do is we help to connect institutional buyers and sellers across the world's financial, commodity, and energy markets. Across the various brands and the technology platforms that we operate, we help to facilitate trading of trillions of dollars a year, and we play a pivotal part in the financial markets. Okay, I wanted to start by outlining a bit more about the cloud adoption journey that we've taken to this date and how that's laid the groundwork for generative AI. So we actually started back in 2013. We were one of the early adopters to cloud in financial services, and notably our Fusion platform was one of the world's first trading platforms to operate in public cloud. Since then, we've been steadily migrating workloads into the cloud, often using data center exits as a kind of catalyst for change and further migration. We've started to reorganize our technology teams around cloud and DevOps, and more recently, we've created a dedicated FinOps function to help us with cost optimization and efficiency. So, taking us to the kind of beginning of last year, we were about 55% of all of our workloads in the cloud. And actually, this has been an invaluable place to start as we enter the Gen AI journey, as we've been able to move straight away into kind of creating value and bypass a lot of the traditional steps in standing up infrastructure. Okay, so I think as we've been hearing about today, generative AI is the fastest adopted technology probably in our history. The pace of innovation is quite startling. Almost every week, something new seems to be emerging. We've gone from models that can create text and help analyze text to models that can create images, and more recently, models that can create full featured videos. And I think it's our view that in time, this will transform the financial services industry. So what we've done is we've established 5 guiding principles to help us steer through this journey. So the first one is we're developing an AI governance framework. So this is to help us navigate the inherent risks that exist in this technology. So this is working with colleagues across the business to understand the emerging regulations that are coming through, to help build the new policies that we need, and ultimately put in the controls to make sure all of our data remains safe. Second is we've taken a decision to partner with hypervisors. So this is a strategic decision to work with companies like AWS to sort of tap into the extensive resources and knowledge that they've got, really with the target of trying to accelerate our own journey. Training and skills enablement we've sort of identified as a key enabler for success. So we're looking to sort of roll out training really across the firm, so prompting training for sort of our everyday business users to more advanced data science training for the technology team. The fourth point is we're developing mechanisms to help us monitor and manage the tools that we do produce, so we can kind of make sure that we are seeing the value that we designed to get. And fifth, and perhaps most important, is that we certainly see AI as a decentralized capability. So we're working with our different business groups and function areas to try and help them to drive their own agendas. And around all of that, we've created an AI Center of Excellence, which is there to help people be successful, work on some of these early prototypes, and ultimately act as the guardrails to make sure that we can keep the firm safe. So in terms of the business outcomes, or the key business outcomes that we're looking to achieve from this work, so I guess first and foremost, enhancing employee productivity. So this is really around kind of trying to create more capacity to execute on our strategy faster. Optimizing operational processes, so we're already working with different areas to look at the processes they've got, look at how we can introduce AI and automation to create new efficiencies. Improve customer experience, so we're starting to look at our data in different ways to see if we can service our customers in a better way, and also look at different ways of communicating with the customers. And ultimately looking at offering new products and services using the new abilities this technology provides. So last year we worked with AWS to create free Gen AI prototypes, solving 3 real-world problems. I'm going to focus in just on one particular area. So to give a bit of context, in general, over the last decade, we've seen tremendous advancements in technology. And with these advancements, we've also seen increased complexity with the technology landscape. So we've gone from applications that used to have a server and a database and a single data center to multifaceted applications that now span data centers across the clouds and have dependency on SaaS platforms. And we've gone from having servers to containers to serverless. And all of this makes life quite complicated for teams like TP ICAP that are trying to manage all of this, and make sure that we continue to provide stable solutions and systems. So what we've been doing over the last few years to try and address this issue is we've been getting all of our data around applications, and infrastructure and network connectivity, pulling it all together, and we've built a CMDB style application on top of that, which enables us to try and manage that, and when we do have issues, help to get the key answers to resolve those. However, one of the challenges we found with this tooling, albeit very valuable and often does have the answers, actually, is that it can take quite a bit of time to actually get the answers that we need from these tools. So the data sets we're talking about are vast. It's often very complicated to sort of dissect the data that we want it. And we have a dependency on quite highly skilled technicians to be able to sort of run these queries and generate the data. Often these same engineers are not available during the night when we might have a production issue. So this really came to a head a couple of years back when we had a DC power issue in our London data center, and we lost a couple of racks, lost a couple of our virtual environments, and actually the key question we were being asked is, what's the impact? Like, which applications are impacted, which business lines are impacted? And although we had the data, we weren't really able to sort of get it in the timeframes that we needed. So the challenge to our team in AWS was, could we build a chatbot on top of all this really valuable data, which effectively allowed us to ask simple questions and get answers straight away. Okay, so the teams worked together. What they created was a chatbot capability which worked within Microsoft Teams, which is our collaboration platform, and also there was a chat part of our UI. And I have to say that it far exceeded our expectations in terms of the results that we got. And if we look at kind of the sort of key outcomes of that, so we've now got a chatbot which can provide immediate access to almost any question. No longer do we need sort of highly technical staff to be able to sort of present that information back. It's all done in natural language, so anyone can ask the question. We've seen a significant improvement in the way that we deal with and resolve production issues because we've now able to federate this information much more widely. And actually, we're finding our user base of this data and this type of application has increased quite a lot, and people are starting to use it to sort of drive further decisions. So overall, we're really impressed with the results we've got. I'm now going to hand over to Iffy, who's going to do a deep dive of the tool and what we've built. Thank you.
Thank you, Andrew. So you've heard about generative AI agents and the power and potential they have in optimizing processes, enhancing creativity, and boosting productivity. But how? How can you get started in achieving these benefits for your business or your use case? My name is Ifa Ojomo. I'm a prototyping architect at AWS, and I'm going to talk you through the key components that this system needs. Firstly, a way to talk to the agent. Secondly, a way for the agent to think. And lastly, a way for the agent to act. So here is the higher level architecture of the solution we built. And on the left-hand side, you can see an answer to a way to talk to the agent. So during the prototype, we focused on two main entry points. The first being a web UI, which is an intuitive interface where you can ask questions to the agent and get back responses. And the second is a Microsoft Teams connector. So this does the same thing, but in a more familiar environment. Key to this solution is authentication. You can't talk to the agent if you have not been authenticated. And this ensures that the right people are getting access to the right data. On the right-hand side is how the agent thinks. This is powered by large language models, or LLMs. So at the start of the prototype, only Claude V1 and Claude V2 were available. But due to the architecture being adaptable and interchangeable, TP ICAP has been able to integrate Claude V3 into the solution today. This ensures that your solution is future-proof against the rapid pace of generative AI that has been mentioned. Lastly, how does the agent act? So once the agent brain gets the query, it thinks about what information it needs. It gets the information from tools, and this is how the agent acts. So each tool corresponds to a custom-built function that was made to do specific things. For example, get a list of databases or get a list of applications. So each tool can be purposely built for whatever function that you need. So let's see this in action. This demo is going to show two views. The first is the end user view in Microsoft Teams. And then when we switch over to the web UI, we'll be doing so in the developer view to show some of the features that we've built in to ease development and prompt engineering. So first, this user has asked a question to the Cell chatbot. It's tagged it just like it would a colleague. This interaction is taking place in a Microsoft Teams channel. So any other colleague who is related to incident resolution will be able to keep track of the past interactions and the past responses. This particular question is to get the trading desks that are mapped to a specific server. Once the user has asked this question, the agent will respond immediately that it is looking into the request. And then shortly after, you'll see a list of the trading desks mapped to a server in bullet point format. So now moving on to the web UI, whether you're in a developer view or an end user view, you have to be authenticated via Okta. And that is the identity provider used by TP ICAP. Notice the ability to select the model. This would only be visible in the developer view, but it ensures that whilst prompt engineering, the developer has access to a range of models to get the best response from the agent. So now it's asking the same question that you saw in the Microsoft Teams view. Above the question box is the box for the system prompt and the user prompt. So these are ways to give more information and more context to the agent. Here you can give your agent a personality, such as you are an incident resolution agent. Or you might want to boost it up a bit more and say, you're an award-winning agent. You also want to guide it to not make things up and only use the tools it has at its disposal. So now the developer has switched to Claude v3, and it's going to ask a series of questions as a rack has gone down and it wants to know what service owner is responsible. Here, the agent is remembering the answer from before because the chat history is being stored. So it doesn't have to repeat the answer each time. You can also notice the thumbs up and thumbs down button, and this ensures that you're giving feedback to the agent. So it ensures iterative improvement and evaluation. Finally, the developer is going to ask to get the service owner, and it will receive a response. So I mentioned prompt engineering before, and you can notice that you can change the system prompt and the user prompt directly in the web UI. And we'll explain how this is done afterwards. Another element of prompt engineering is the use of tools. In the web UI, you can enable or disable different tools, as well as changing their descriptions. So you can see that if the agent is constantly choosing a different tool or the wrong tool, you can disable it and see if it makes a difference. If it does, you might want to change the name of the tool or change its description. Lastly, on the left-hand side, you can see the chat history of the agent. And this is also possible in the end user view. And this just ensures that you're able to keep track of previous interactions, or if you're prompt engineering and experimenting with different models, you can see and compare the different responses. So now we're going to dive into the architecture that makes everything you just saw possible. Firstly, the entry points of the web UI and the Microsoft Teams connector are integrated into the architecture using a REST API and a Lambda function. The REST API is powered by Amazon API Gateway, and this is just a service that enables developers to easily create APIs, manage them, monitor them, and secure them at any scale. The Lambda function manages the conversation and the tools of every agent interaction. Because each entry point is connected via a REST API and a Lambda function, this makes it very easy in the future if you want to add more connection points, such as a different application, or you want to subtract. It's decoupled in a way that you can easily extend your architecture. So when a user logs in, the authorizer Lambda ensures that it is authenticated against a Cognito user pool. Amazon Cognito is an identity provider. And a good thing about Cognito is that it integrates with different identity providers, such as Okta, which is the enterprise provider used by TP ICAP. This means that you're not having to create new roles or new users. It's essentially using an already existing user base to ensure that the right people get access to your data. So it will try and validate your token against this user pool. And if it is successful, it will generate a policy that allows you to invoke a WebSocket API. Upon signing out, it will remove this connection from a DynamoDB table, which is storing details about your user and the connection. The WebSocket API is also powered by API Gateway, and this ensures real-time bidirectional communication. So the agent is able to listen and respond at the same time. You're not having to restart the connection each and every time. So the conversation ends up being as smooth as a phone call. It's ongoing, it's persistent, and it's at low latency. Now we're going to jump to how the agent thinks. So once the agent has received your request, it will think about what tools that it needs. This is all done using a LangChain library for agents. And this LangChain library needs you to define what your agent is. You'd first define it by using an LLM. So as I mentioned, we use Claude v1, Claude v2, and now Claude v3 has been integrated into this architecture. This is all made possible by using Amazon Bedrock, which is able to host your fully managed models to ensure that you have access to the most up-to-date models for different reasons and different purposes. Once it creates a list of tools that you have specified, it may suggest different tools and invoke certain tools to get the responses that it needs. So we're going to dive in a bit more about what tools are in the next slide, but essentially, your LLM is making up the agent, a list of tools, the system prompt and user prompt that you saw before. And then once it receives a request, it will create an action plan, as Gaurav mentioned before, and specify what tools are needed to get what, to get the specific information to respond to the user. So now let's jump a step back into when we were authorized using the authorizer Lambda. Once a user is authorized and sends its first message, it will send a message, the user ID, and the connection ID to a simple notification service queue. And what this acts as is the message dispatcher. So it dispatches that message to different endpoints, namely a simple queue service queue. This ensures that irrespective of the amount of requests that you get, it's making sure each and every message is being processed, irrespective of the scale. And so you can see this SNS as decoupling your messages and fanning it out to different endpoints. The SQS queue will then pass that to your agent. As I said, it will decide what tools it needs, and then this process is back and forth, back and forth, back and forth. So as it learns more, it's also responding at the same time until it gets that final message response and sends that back to your user using an SQS queue, going via SNS, and then going back to the Lambda function. I also said that we're going to dive into what tools are. So each tool is powered by a Lambda function. And in this prototype, most of the tools were specified to query the database of TP ICAP. And this database was in RDS. Doing it this way meant that the agent didn't have to come up with complex SQL queries or worry about what joins to use or what database to query. All it needed to know was what tool do I need to get this specific information. Tools can be custom built to whatever you want them to do. So later on in the prototype, we moved away from simply querying the database and also generating a report. So whatever your use case is, if it's incident resolution or something else, you're able to build custom tools via Lambda functions that do this. So key highlights for this architecture is that it's decoupled. So I mentioned that you can subtract and extend different entry points, so not just using Web UI, not just using Teams. You're also able to quickly reduce or extend the amount of tools that you have. So the architecture is decoupled. You can use different models. You can use different tools. You can use different entry points. And you don't have to make huge changes to your code. Tool development is streamlined by using Lambda functions. And Lambda functions are serverless, which means that you're only paying for the compute that you use. They're adaptable, they're cost-effective, and lastly, they're secure. So this means that only the Lambda function is getting access to your data, and by using IAM roles, you don't have to worry too much about making sure that your data is not exposed to more endpoints than it needs to. And that links into the robust security of this solution as well. So by using Lambda functions, it's secure. By using IAM policies, it's secure. And as I mentioned in the beginning, authentication via Cognito and Okta ensures that the right people are getting access to the right data. And lastly, this architecture is future-proof. That means that you're able to use different models. If this agent expands to different use cases, you can explore image models or video models, but you don't have to change that architecture. All you're changing is the purpose of your agent. So with that, I'm going to pass over to Gaurav, who's going to talk about how you can get started today.
OK, thank you, Eva. And thank you to you for sticking around for the last bit. As I said, there's going to be a slight bit of good news on the next slide. But what I wanted to do was round up all of this content and ensure that you know how to get started with this. So here's the good news. Some part of what Eva just spoke about is all combined into a single service that now we offer called Agents for Amazon Bedrock. The connectivity with your knowledge bases, your internal databases, the security, the chain of thought, all of it is combined into a single service called Agents for Amazon Bedrock. What you also get with Agents for Amazon Bedrock is a trace, whereby you can understand why the agent is doing a specific task. So it's like explainability. It tells you it's taking a particular action, and this is the reason why it's taking that action. I'm really excited to see what some of you will build with this service, and hopefully in the next few slides I can inspire you with some of the use cases that we see more commonly. Okay, some of the use cases that we see more commonly, I've split it up into 3 domains. First is enhancing your customers' experiences. Second is about boosting employee productivity and creativity. And third is optimizing your own business processes. Let's dive into some use cases for each of these domains. Now, as someone who wears spectacles, I use my vision insurance quite a bit in terms of expensing out if I'm buying, say, new spectacles, right? How that traditionally works is I take an invoice from my retailer, upload it to my vision insurance provider, takes about 5 to 7 business days, and I get expensed the amount I'm owed. Now, rethink this using an agent. I take an invoice from my retailer, upload it to an agent. The agent looks at how much money I've spent, goes into a knowledge base which contains my vision policy, understands how much I'm owed, and transfers that money into my bank account without a single human interaction taking place. Imagine how much money and how much time the vision insurance provider can save on their human costs. You heard Andrew and Eva speak about incident resolution. Agents can also help you create content, whether it be content for your recruitment department for writing job descriptions, or be creating content for hotel descriptions. We recently worked with a travel provider that needed support on creating the first draft of hotel descriptions. It can also help us summarize meetings, as you saw in a previous example. I'll take it a step further. For your IT department, agents can help you order new laptops. I recently ordered a new laptop in my own company, and agents can help you order a new laptop directly without a human interaction. IT agents can also help you unlock your accounts if you're locked out without you having to go through any tedious manual approvals, because that agent already knows who you are, what policy you hold in that particular company. Now, to get you started, I've listed down 2 resources which I think is really important if you want to get started with agents today itself. The first is a demo for Agents for Amazon Bedrock. It'll help you understand how the service works and give you a few good examples. The second QR code will take you to a more deep dive into our generative AI services, including Amazon Bedrock. This comes in with an angle of financial services, but the interactions and the courses it provides you in the bootcamp is generally applicable to other industries as well. If you want to continue your learning on AWS, I heavily recommend signing up for skillbuilder.aws as well. It has over 600 free courses and lectures that helps you understand how AWS technology works and upskills you on AWS technology. Now, before I close out, thank you to you for sticking around for such a, nearly last 40 minutes with us. Hopefully, we're able to help you explain what generative AI agents do and some of its real business applications. I'd also like to thank Andrew and Ifa, partners in crime, for sharing some of their knowledge with you today and hopefully inspiring you as well. If I might ask you for another last task, is to fill up the survey on your phone applications. It really helps us improve to deliver these sessions better the next time we deliver it. Again, thank you so much, and hopefully you have a good rest of the session.